We're on the page 18, and it says, hey, we got f prime here, and then we have this domain. It says, find the x-coordinate of a critical point. You guys, we want to remind ourselves, what the heck is a critical point? That's when that derivative equals 0 or that derivative is undefined. That's what we're looking for every time for a critical point. Then they want us to tell ourselves, is that a max, min, or neither? So they gave us f prime. We got to go figure out where this equals 0 for us to have a critical point. Where does this equal 0? How would we do that? Ooh, and? Don't we always multiply by that denominator first? Push, push. So I get x squared minus 16 equals 0. My girl L said, all right, I know the square root of 16 is plus or minus 4. Why do I get to leave off the minus 4? Yeah, it's outside my domain. We don't need to worry about it. So we can just say x is going to be 4. That's the only one we care about. And I can't erase. Great. So we're going to just say this. 4. Great. 4. Positive 4. That's one critical point. Is this ever going to be undefined? Yeah, that's when my x would be equal to, careful, negative 2, right? Because my denominator would be 0 at negative 2. Do we care about it? No, because it's outside my domain again. So we actually, in this case, only have one critical point. You okay, Haji? Okay. So our only critical point is that x equals 4. And then they said, hey, go find out if that's a max, min, or neither. You guys, that's when we got to go put it on this little sign chart. 4. 4 is my only critical point. That goes on my sign chart. That's an x value. I'm going to see what sign it is when I plug it into my function. What's a number that we want to plug in less than 4 that's still in our domain? 2. 3. Could I plug in 0? No. Yeah, I can't since it's not in my domain. Very good. What we got to do is plug this number into f prime. Oh, when I plug it in here, a 3, would the top or the bottom be positive? Would the top be positive or negative? Negative. What about a 3 on the bottom? Negative over a positive? It's a negative. When we're to the left of 4, my f prime is negative, therefore my function is decreasing. Ready, Rick Dog? Bigger than 4. What's the number bigger than 4? 5, sure. 7. You were too late. If I used a 5, what would be up top? Positive over a is a. What do we have at 4? Yeah, so all we're going to say is we've got a min at x equals 4 because I wish I had gummy bears or Haribos for who could give me the f prime. Perfect. Changes from negative to positive. You want. Okay, you guys. Now it says, hey, for what value of k do we have a maximum of 10? Do we have a maximum of 10? Is that saying that my maximum is when x is 10? Nah, it's saying that my maximum is 10. The y value is 10. It says for what value of k does this function have a relative max of 10? This would be the y value. And they're asking at what value for that k. So how do we know when we have a maximum? When f prime does what? When f prime goes from positive to negative. We can't say increasing because actually my f primes would be decreasing. They'd be approaching 0. So when f prime goes from positive to negative, we know we've got a max. We got to go get f prime, y'all. We got to go get f prime. Let's go do it. What would f prime be of this function? 3x squared minus 12x plus, and k is a constant, so what's that derivative? 0, right? Nothing? Okay, we got to go figure out if it changes from positive to negative, it's going to have to go through 0. So let's go see when this is equal to 0. How do we factor that? What are we taking out first? Yeah, take that 3 out. X squared minus 4x plus 3. Toot or o-toot? Yeah, what multiplies to be 3 adds to be negative 4? Negative 3 times negative 1, negative 3 plus negative 1. I agree. So it says, for what value of k do we have a relative maximum here? Well, where does this equal 0? What are my critical points, if you will? 3 and 1. And that's telling us the x values. These are the x coordinates that we have critical points. We got to go do our little sign graph. To see where we've got a max. Let's go see. If we do our sign chart, and I'm going to put 1, then 3, because those are my least to greatest. Those are my x coordinates. That's going to tell me what my f prime is doing, therefore what my function is doing. Okay, what do we want to plug in less than 1? Sure, if I plug in 0, I like to go to this of the factored form of f prime, because then I don't have to get a value. If I plugged in 0 here, would I get what would this be, positive or negative here? Negative times is cool. I got f prime is positive there, which means that my function is increasing. What number are we trying between 1 and 3? 2. If I plug a 2 in here, positive or negative? Negative times is negative, decreasing. Bigger than 3? Oh, come on, where's the 7? There we go. If I put a 7 in here, positive times is great. I never really looked at my 3 because it was positive anyway. It didn't influence it. You guys, where's my max happening? Yeah, do you agree that my function was going like this? Woo, woo, whoop. So we have a max, a relative max at 1, relative min at 3. They said, for what value of k does this have a relative max of 10? Anyone have an idea of how we could figure out what k is? We know my x is 1. We know we have a max at 1. And set it equal to 10. My f of x is going to be 10. So we're going to say, all right, when does 10 equal? I apologize for the lack of space here. My bad. You can go anywhere down here, though, because we will not need this space, you guys. Any of this space, we will not need it. When does 10 equal x cubed minus 6x squared? Oh, wait. What are we putting in for my x's? Yeah. 1 cubed minus 6 times 1 squared. You do not have to write it that way if you don't want. You could just know that 9 times 1 is 9. And I'm going to simplify. 1 minus 6 plus 9. See you at the end. So it said, hey, for what value of k, as long as this is 6, my maximum is going to be at 110. Sound good? Cool. That's a lot of algebra right there. Whew. They might do a free response like that. They could. You guys, let's take a peek at this graph. They gave us f prime. Okay, before you even look at this graph, let's think about what this means. F prime. They want to know where my function f has a minimum. You guys, if this is my function and it looks like this, woo, this is just a function. To have a minimum here, this is just f, to have a minimum there, what is f prime doing? Ooh, careful. F prime changes to have a minimum. What's my f primes here? Yeah, then what are my f primes? Yeah, so I'm saying negative to positive. That's my little note here. My f primes need to change from negative to positive. What are my f primes here? They're negative values. What are my f prime values here? Positive. What are my f prime values here? So you guys, I'll never forget Molly Smith. Every time she would see any graph, she would always do this, plus, 0, minus. She would always do that to remind herself anything above the graph is always a positive y value. Anything on the x-axis is just a 0 value. Anything below that x-axis is a negative value. These y values are negative. These y values are negative. So where does my f prime, this is a graph of f prime, when do those signs change from negative to positive? Yeah, Viv?
But didn't you say that a min is when it changes, when f prime changes from the negative to the positive?
Correct.
So we're looking for like max.
Oh, I didn't know that. I just saw that and I read minimum. Okay, would you guys agree a maximum is like Viv had said, if this is a graph of f, a maximum is when f prime changes from positive to negative. Whoo, Viv. Appreciate you. We aren't looking for a minimum. We're looking for a maximum. Where are my f prime values changing from positive values to negative values? 1. Is that it? Agreed. Yeah. Is this a mind game, you guys? Are they trying to get you to say, ooh, positive to negative right here? What is actually changing from positive to negative at -1? F double prime is changing from positive to negative at -1. What is changing from negative to positive at 3? F double prime. So they're just trying to get you. Oh no, Murph Dog's sleepy too. Oh boy. Let's just try 82 together, then I'm going to let you do this on your own. Okay, you guys, let's take a peek at 82. What are we looking for a maximum? What is my function? I'm going to try to read this correctly. For a function to have a maximum, if here's my maximum of f, what did f prime do? Yeah, from positive to negative. Let's go look. What did they give us? They gave us f prime. Let's go take a peek at it. Let's go take a peek at f prime, which was root x to the 4th plus 1. Get out of that root. Plus x cubed minus 3x. Okay, so my graph kind of looks like woo, whoop. And we want to know where my f prime, this is a graph of f prime. This is f prime. Where it's going from positive to negative, where am I going to see that on my graph? Where do these values go from positive to negative? What are these values of f prime? Negative, what are these values? Positive, what are these values? Oh, so don't we need that right there? It's going from positive to negative right there. Second trace, what are we looking for? A 0. Go to the left of that point. Go to the right of that point. Yeah, this is graph of f prime. Did you guys get 0.35? Yes. Yeah. Okay. The time is now yours. Here's what I want you guys to try with the peeps around you. That question right here, I'm going to highlight them. Ready? 85. Give that a shot. 85. As well as 87. Ooh, pay attention to the calculator active versus not calculator. Most of these are oh my God, this whole page is. So just that whole page. That would be great. Actually, you ready for me to be, we're gonna keep it going, people. I want you to keep going. E, D, Go ahead and try those on your own, OB. You're going to do this one. You're going to do this because these are both good ones. Yeah, I'm going to give you some time. And that's it. And then on 79, we've got B. You'd have to do F prime minus G prime. On 84, we got C. And this is at x equals -2 because F prime changes from positive to negative. That's it. This guy, this is just the last one of 5-4, page 21. You guys, there's a lot of info, and I actually gave a part of this question on a test before. Not this part, though. It says, find the x-coordinate where we would have a minimum from -2 to 3. Look where -2 is. Look where 3 is. That's my interval. Where do we have minimums? What I have to do, I've got a picture. Correct me if I'm wrong, Viv. A minimum looks like that, and that's what we're looking for, right? Whew. Okay, that's a minimum of a function. Why do we have a minimum? How do we have a minimum when f prime changes from negative to positive, right? You guys, when they say ask for a justification, boom, that's it. So I like to do that justification before I give them any kind of answer. I just got myself a point. F prime changes from negative to positive, and where in this table is my f prime? Because look what they asked. The minimum of f. That's how I know I get to focus just on f. Look what we got up here. F, f prime, g, g prime. You writing this is telling us where to look. Where's f prime? Which row? 1, 2, 3, or 4? Yeah, f prime is in this row. Where, at what x value do you think my f primes are changing from negative to positive? Yeah, negative to positive is happening at 1. That's a lot to sift through, if you will. So I'm going to just say f prime changes from negative to positive at x equals 1. That's where my max is. Min. So right now, what we've got now is we've been talking about relative maxes and mins, or what's going on inside my function. What 5.5 is about is to talk about the absolute maxes and mins. Well, when is that ever going to happen? If I ever have a graph like this, if I've got my parabola, yes, I could have an absolute min right there, right? That is my absolute min. But it's going to happen a lot more often when they cut off if they give us a closed interval on our graphs. So like this picture here, let me go back it. So it says, if we just look right here, a function that is always decreasing. Do you agree this function is decreasing? This is just a good old f graph. Do you agree it's decreasing because f prime is what? Negative. And how Miss Eleanor writes it is f prime is less than 0, right? That's how you're going to say it. A max and a min. If this is a closed interval, you guys, this goes from, say, -3 to 5. Where is my absolute max going to be? On the left endpoint? Isn't that going to be my absolute max in this graph? And then over here is going to be my absolute min. And that's only because my graph was closed. This is giving us a closed interval. This one says a function with one interior point called with a maximum, the minimum in this graph. Do you agree my absolute minimum is going to happen down here? My global or absolute minimum would be there. What would we say is up here? Right here. That's my absolute max. Again, this is a closed interval. So what could I say is going on to this blue point? Relative min. Very good. Min, because it's going down there. So when we've got these closed intervals, we really got to look at these endpoints, and that's a new thing as of today. So let's flip that page. So looking at this graph, it says that the Candice test is your go-to way to justify the absolute extrema. So where are we having potential maxes and mins? Again, this is just like an F graph. What do we have here? Local max, because my f prime changed from positive to negative. What do we got here? Local min. What do we got up here at this not differentiable point? Absolute max, because this is a closed interval, so nothing else is going on. And then over here, do we still have extrema here? We sure do. Oh, wait, I missed one. What do we have down here? Yeah, that's my absolute minimum. So my critical points still help us find extrema, but we also have got to look at these endpoints because those are gonna be some other extrema. This one over here, what would you call this one? A local min, and about this one? Local max, and I'm not too worried about those. So I can skip how to find the extrema. We're gonna find those critical points, and maybe we want to remind yourself, that's when f prime equals 0 or f prime is undefined. What we got to do to find the absolute extrema is list those critical points, but we can't forget about the endpoints either. So the new thing today is we got to add endpoints. We're not really going to make a table, I'll show you, and then just see where my max y values and my min y values occur. So let's take a peek at this cute little function here. They said applying the candidates test, a continuous function. They didn't even tell us what the function is, but they did say that there are two critical points. You agree my f prime would be 0 here and here. And they put those critical points right here. I'm going to put CP, critical point at -4, critical point at 2. Those are critical points. That was when my f prime equaled 0. So you guys, they said, hey, find, if we're looking for my absolute max and min, if we know that this went from -5 to 6, this is where that -5 came from. They said, we got to look at my endpoints. -5 and 6 are the other x values that we had to look at. Why don't I have the equation for you? I'm not sure. I'm just going to give you the values. The y value at this point over here was negative 1.05. The y value here was negative 1.6. The y value here is 4.3. And the y value down here is negative 7.167. Which one of these would be my absolute min? Say that again. Oh, yeah, I'm sorry, I was looking up here. Yeah, you're saying this one, it's going to be my absolute min because my y value is the smallest there. We could have looked at that on the graph. Where's my absolute max going to be? At 2. Awesome. My absolute max has a value of 4. And that happens at 2. Okay. That's a lot. Let's go try this on our own. So it says, hey, here's this function u of e to the x times cosine of x. Find the absolute min value. They aren't asking where the min is happening. They want to know the value, the y coordinate. Ooh, how do we find minimums when f prime goes from negative to positive? So that justification, boom, I'm going to say f prime changes from negative to positive. That's my justification. We just got to go get an answer there. F prime changes from negative to positive. We got to go find f prime. Ooh, I snarled because what rule do we have to do to go find f prime? Fig plus gif. Nah, this is product rule, not chain rule. Okay, f prime. Woo! What is the derivative of e to the x? That's f prime g. Perfect. Plus g prime. Nice. I'm going to change that plus to a minus sign times f. Perfect. You guys, for something to change from negative to positive, guess what it's got to go through? 0. So what we're really curious about is where does this equal 0? How do you think we could start solving that? Can we move that sine of x times e to the x to the other side? Heck yeah, we'd have e to the x cosine of x. Where does that equal e to the x sine of x? That's in between 0 and 2 pi. Good call. We notice our domain. Am I allowed to cross out these e to the x's if I divided them out? Yeah. You guys, where does cosine equal sine at what x value? Yeah, at pi over 4, right? We got root 2 over 2, root 2 over 2. Is pi over 4 in my domain? Okay. They didn't ask what the x value is. They said, what's the min there, the absolute min? What we just found, you guys, is a critical point. We just found a critical point. So what I would do is instead of this quote unquote table, we're going to just say, okay, we got to just build. And I apologize. Do you have enough space? If I were you, I would do something like this. I got to go check my endpoint. So I'm going to say what's going on in my function at my left endpoint, which was 0. What's going on at my critical point, which is pi over 4. And what's going on in the right endpoint, which is 2 pi. Now, I did not make a sign chart because in order to know where the absolute min and max happen, we got to just go look at the value of the function there. Again, this is going to be the value of my regular function. Find the minimum value of f. Can we plug in 0 here? What's going to be e to the 0? E to the 0 times the cosine of 0. Yeah, cosine of 0 is 1, so that we got a 1 there. Okay, what if I put in a pi over 4? E to the pi over 4 times the cosine at pi over 4. E to the pi over 4, we have no idea what it is, right? Cosine at pi over 4 is root 2 over 2. Okay, I have no idea what that value is, but they were looking for a minimum. Okay, let's go try 2 pi. E to the 2 pi times the cosine of 2 pi. E to the cosine of 2 pi is 1 times e to the 2 pi is we got e to the 2 pi. Uh-oh, we left off one domain. You guys, does cosine equal sine anywhere else other than pi over 4? Pi over 4 and 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Wouldn't it be a negative then a negative? So we've got to try one more, f of 5 pi over 4. So we have e to the 5 pi over 4 times the cosine at 5 pi over 4. What's the cosine at 5 pi over 4? Negative root 2 over 2. So when I've got e to the 5 pi over 4 times a negative root 2 over 2, which of these is going to be the smallest value? This one's going to be the smallest value because it's the only one that involves that negative. Multiplying by negative is going to make it the smallest answer. So it says, find the absolute minimum value. This is the absolute minimum value. It happened at 5 pi over 4. So it says f prime changes from negative to positive at, we can say 5 pi over 4. And the minimum value is e to the 5 pi over 4 times negative root 2 over 2. Whoa, that was it. Have a good one, y'all. Have a great day.